Hello everyone. Welcome to today's show. Today's date is April 29th, 2026, and it is a wonderful Wednesday. I am your host, Sando, and I am super excited to be here with you today, broadcasting from my cozy little studio. Today I'm introducing a really cool and trending article from the archive, but it's a bit technical, but I promise we will make it super fun to understand. The title is GAMMAF, a common framework for graph-based anomaly monitoring been marking in Anomaly against systems. The crew is oxide to 6A4 for 24,477. It's long, but do not worry, I'm going to break it all down for you. Let's talk about the big problem that this paper is trying to solve. Nowadays, we have these amazing large language models, which are like super smart brains that can talk to us. And recently, scientists have been putting them together into what they call multi-agent systems. That means multiple AI agents are chatting and working together to solve really hard problems. Kind of like how we do group projects in school. But just like in a real group project, sometimes one person gets totally bad information. And if they are really loud about it, they can spread that wrong info to everyone else. In the AI world, this is a huge security risk, and it exposes them to scary things like prompt infections or compromised inter-agent communication. Basically, bad guys can sneak a malicious agent into the group chat and make all the good AI agents make terrible mistakes. And to fight this, researchers have been making graph-based defense methods. These are special security guards that look at how the agents are connected, like looking at a map of who is talking to whom, to catch these bad agents. But the big problem this paper highlights is that there is currently no standardized or reproducible environment to train these models and evaluate if they actually work. Everyone is just testing their defenses in their own secret ways, and it is super hard to compare them fairly. So to address this gap, the researchers created GAMMAF, which stands for Graph-Based Anomaly Monitoring for All Multi-Agent Systems Framework. It is a completely open-source benchmarking platform. It is like a special, standardized testing playground designed to generate fake debates between AI agents and see if the defense models can catch the bad guys in real time, if we compare this to other technologies. And traditional security testing usually just looks at static data. They just feed the AI a bunch of frozen text and see if the model spots the error. But GAMMAF is totally dynamic and alive. It actually runs the group chat in iterative rounds. And when a defense model flags a bad agent, GAMMAF actively kicks that agent out of the chat, severs their communication channels, and sees if the rest of the good agents can still finish the task correctly. That's right, it is like playing a real-time game of finding the impostor. And it makes the testing so much more realistic than older methods. Now you might be wondering, how does this apply to our everyday life? Well, as AI gets smarter and more integrated, we are going to rely on groups of AI agents for really important stuff. And we give you 3 specific application examples to show how this technology and the concepts discussed in this paper could be applied in the real world and what amazing impact they might have. First, think about a high-tech hospital using an AI medical board. Imagine a group of AI agents working together to treat a patient, where one agent specializes in reading X-rays, another looks at blood tests, and another reviews the patient history. They all talk to each other to figure out the best treatment. But what if a computer virus changes the blood test AI, making it give totally wrong results? Without a good tested defense, the whole AI team might agree on a wrong diagnosis. By using the GAMMAF framework to thoroughly test their security models, hospitals can make sure their AI teams can spot the hacked agent, dynamically cut off its bad advice, and still keep the patient completely safe. Second, let us look at the world of financial trading systems. Big banks use lots of AI agents to monitor the global stock market, check the daily news, and decide when to buy or sell stocks in milliseconds. If a malicious agent sneaks a fake news story into the group chat, the whole network might panic and lose millions of dollars. Financial companies can use GAMMAF to benchmark their graph-based security models, making sure that if one AI agent starts acting suspiciously, the system will immediately isolate it before it ruins the whole trading strategy. That's right, having tested defenses keeps our economy much safer and prevents huge financial disasters. Here? Imagine a smart city traffic control network. Different AI agents control the traffic lights at different intersections across the city. And they constantly communicate to keep cars moving smoothly and prevent jams. If one agent gets hacked and tells the others to turn all the lights green at once, it could cause massive and dangerous accidents. By evaluating their security with the dynamic rounds in GAMMAF, city planners can build super robust networks, where the good traffic agents realize the infected agent is lying, and they just prune its connection, keeping all the drivers and pedestrians perfectly safe on the roads. It is just so amazing how these researchers are thinking ahead. To really dig deep into the paper, the framework operates through two main pipelines. First is the training data generation stage. This stage simulates debates across different network shapes, like star tree chain and random topologies. It captures all their interactions as robust attributed graphs. And then, the second pipeline is the defense system benchmarking stage, where it actively evaluates the defense models. They even tested it using established baselines from other studies, like 6Guard and GleanGuard, across really hard knowledge tests like MUPRA and SMIC. The experimental results they got were just super interesting. They tested the defenses across really hard knowledge tasks, like MUPRA, which has diverse knowledge questions, and so about grade school math. What they discovered was a big difference based on the subject. For the math problems in SMIC, the good agents were pretty confident in their answers. And it was really hard for the malicious agents to trick them, because it is hard to make up a fake math proof that looks real. But for the MUPRA dataset, which has lower certainty, the bad agents were much more successful at spreading misinformation when there was no defense mechanism in place. This shows why we need a diverse testing environment like GAMMAF to truly see how different types of tasks affect the security of the whole system. Also, they measured things like the attack success rate, which is the percentage of the group that gets tricked into giving the wrong answer, and the adversarial detection rate, which is how many bad guys the defense correctly catches. When they turned on the baseline defenses like 6Guard, the attack success rate dropped massively, and the detection rate went super high, often catching over 90% of the attackers. That is a huge improvement, right? Furthermore, they looked at the efficiency of running all these tests. Running multiple AI agents at the same time takes a lot of computer power. But GAMMAF is designed to be super efficient. It allows concurrent requests to the underlying language model, which drastically cuts down the total time it takes to run a benchmark. They showed that even as the network of agents grows larger, the system scales predictably, so researchers can estimate their budgets and time required without any nasty surprises. That's right, it makes it so much easier for scientists everywhere to do their research. And like I mentioned before, equipping a multi-agent system with effective attack remediation not only recovers the integrity of the system, but it also substantially reduces the overall operational costs. Because the bad adversarial agents tend to talk a lot, generating extensive tokens to try and convince everyone of their lies. So by cutting them off early and facilitating early consensus, the system stops all that unnecessary text generation and saves a ton of money on computing power. That is like a double win. You get better security and you save your budget. I think it is absolutely fascinating to see how AI is evolving. We're not just making them smarter. We are making sure they can protect themselves. and keep working together, even when someone tries to mess them up. It is like teaching AI how to have good street smarts, and not just book smarts. Thank you so much for tuning in and listening to my show today. I hope you found this deep dive into AI security as exciting as I did. Have a super fantastic rest of your Wednesday, and I will definitely see you next time. Bye-bye.